So in the last video what you have seen is you have seen how to use the T table and Z table. So there are two types of samples available to us. One is the small sample and another one is a large sample. With respect to statistical inferences, we are going to compare the sample mean with the population mean. If it is a large sample, we are going to use the Z test for it. Okay. Now let us see. This is the Z table. If it is a large sample, that means the sample size n is 30 or more, we should use this table. Okay, so if the sample size is given more than or equal to 30, you should look for the last line only. This place you can see, only come to this line and you can take the values from here. Choose the tail of the test in every question. First you should frame a null hypothesis, then frame a alternate hypothesis. The alternate hypothesis will tell us whether this is a one-tailed test or two-tailed test. In this example, we assume that we are going to find the value for a one-tailed test. Okay. If you are going to find the value for a one-tailed test, you should take this row for our consideration. Okay. Now, for every test, there will be a level of significance. That means how much error we can allow. Normally, it will be 5%. If it is a general statistics not related to any human lives, not very sensitive, means we will take the level of significance as 5%. If it is given to you in the question, you can take the percentage. It may be 1% or 2%, or if it is not given, by default you can take it as 5%. 5% means 5 by 100, that is going to be 0.05. Okay, so look for the value 0.05 here, 0.05. Now take this row and this column, we are having 1.645 in the middle. So 1.645, that is the table Z value. Table Z value for one tail test for 5% level of significance is 1.645. This is how we have to use the Z table. Now let us see some questions. A manufacturer claims that its rechargeable batteries are good for an average of more than 1000 charges. Now, a random sample of 100 batteries has a mean life of 1002 charges and a standard deviation of 14. Is there enough evidence to support this claim at alpha is equal to 0.01? So this is the question. So how to start this question? So first let us try to understand what is the question. A battery, okay, rechargeable batteries, a company, they are telling that their batteries can be used for more than 1000 charges. Okay, you can put it in the charger for more than 1000 times, it will work. So that is what the company is giving the guarantee or surety. But we want to know whether he is saying correct or not. We will do a testing for that. So how to do a testing? We are taking 100 batteries. We can go to the shop and we can take 100 batteries from the company manufacturing, and we test them each and every one. We can give it to 100 peoples and we can collect them how many times they are using that battery, and we take the mean value for that. So it is showing that from this 100 batteries the mean lifetime is 1002 charges, and we calculate the standard deviation, it is 14. Okay. Now after getting this data, what we can decide whether the company guarantee is correct or not. So that is the question. Now the answer is, first we should see which test we should use. Here we are using the average values, average. Okay, it is a mean and mean. So if you are comparing two means, we are having two tests. One, you can use a T test, use a Z test. So which one is the correct one? Now look at the sample size. If the sample size is 30 or more, you can use Z test. If the sample size is small, less than 30, 29, 28, 20, 14, 10, like that, if it is coming, you should use the t test. Okay, so please understand the classification. If you are testing the mean, you should use a t test or a Z test, and if the sample size is small, you should use a t test. If the sample size is large, more than 30, 30, 31, 32, like that, if the sample size is coming, you should use a Z test. So first thing is, we are deciding that for this question Z is a suitable test. Now we frame the null hypothesis. What is a null hypothesis? Null hypothesis is whatever the company is saying, that is going to be the null hypothesis for us. Okay, there is no change. That means company is claiming that the batteries are good for an average of more than 1000 charges. That is the company's claim, that is correct. Okay, now what is the alternate for that? Alternate is going to be less than 1000. Okay, if the battery is not working for more than 1000 charges, suppose after 500 charges the battery is dead, we are not able to use, so that is the alternate hypothesis for us. Now the alternate hypothesis is only one side, it's coming less than, so this is going to be a one-tail test. Okay, one-tail test. What is the level of significance? It is given the level of significance is alpha equal to 0.01. It is given to us in the question. So take alpha is equal to 0.01. So this is the null hypothesis, alternate hypothesis, level of significance, and one-tail test. Now let us take this data from the question. Okay. Now what are the datas? The datas are going to be Z equal to x bar minus mu divided by sigma divided by root of n. So this is the formula for Z test. When you are taking the Z test, you put the values x bar is the x bar is 1002. Okay, x bar, this is the mean we have calculated, so that is a sample mean is 1002, sample standard deviation is 14, sample size n equal to 100. So then we substitute them in the formula, x bar minus mu divided by 14 into square root of 100. Okay, this square root of n go to the numerator, okay, into square root of n. So n is, we have taken 100 batteries, so you put square root of 100. Now after doing this calculation, take the magnitude. Okay, take only the positive quantity. The positive quantity is equal to 1.43. In fact, if after doing the calculation, you will get positive 1.43. Sometimes you will get minus value also, so don't take the negative number, take only the positive number. So this Z is called the test statistics. Okay, so by doing the practical test, we are finding this value. So this is a test statistics. Now after getting this, how we can claim this is right or wrong? Okay, the company's guarantee is right or wrong. Now you should go back to the Z table. Okay, so this is a short form of the Z table, I put it here. Now where we have to take it is, our alpha is equal to 0.01, it is a one-tail test. So one-tail test, you can take it from here, and 0.01 come here. Okay, then n is greater than 100, that means you should take only this line, okay, Z line. So in this line, what is the table value? It is coming 2.326. So this is the value, 2.326 is the table value. Take it down. The table value is 2.326, that is the table value. Now you have to compare this calculated value with the table value. Always keep the table value in the left side, 1.43 in the left side, and take the table value in the right side. When you are keeping like that, you get, so let us take the values from here. You will get 1.43 in the left side, so that is the value we have calculated, and table value is coming 2.326. Check is it less than or not. This is clearly less than. If it is clearly less than, you can say H0 is accepted. Okay, what is the H0? The battery is working for more than 1000 charges. Okay, the company's claim is accepted. In case if the number is coming more than 2.3, something like 2.5 here, if it is coming, you can say H0 is rejected, but in this case it is not that. Okay, this is how you can make a decision on a statistical test. So what are the steps? First, you should design on which test you are going to use. It is based on the sample size. Then frame the null hypothesis, alternate hypothesis. So alternate hypothesis, you can check the question. If there is some word like more than, less than, something like that, if it is coming, so definitely it is going to be a one-tail test for us. Then take the alpha given to us in the question. In this question it is given alpha is equal to 0.01. If it is not given to us in the question, 0.05, that is 5% is the default value. Okay, if it is not given to us in the question, you can take this. Then based on the sample size we choose a Z test. So this we have done in the first level. So this is for the Z test. A telephone company claims that the average length of a phone call is 8 minutes. In a random sample of 58 phone calls, the sample mean was 7.8 minutes and the standard deviation was 0.5 minutes. Is there enough evidence to support this claim at alpha equal to 0.05? So what are things it's given? It's given a sample mean and a population mean. That means we are going to use the t test or z test. Now look at the sample size in a random sample of 58 phone calls, which means this is going to be the large sample. For large samples we should use a z test. Okay, so what is our null hypothesis? Null hypothesis is always the company's claim is right, company's guarantee is right, there is no change in the system. Okay, like that you take it always positively. The company claims that the average length of a phone call is 8 minutes. Okay, so that means mu equal to population mean equal to 8. What is the alternative? We are going to test it whether they are giving the right information or not. Both things are possible. The call can come for more than 8 minutes. They can use the call for less than 8 minutes. Both things are possible. So we put mu is not equal to 8 is the alternate hypothesis. Both sides are possible means it is going to be a two-tailed test for us. Okay, so now level of significance is given to us in the question. It is alpha is equal to 0.05. Okay, please make sure that if they are given the number, you can take it as 0.05. If they are given in terms of percentage, you should divide that number. If they are saying 5% means 5 divided by 100, you should divide it. Okay, here it is simply alpha equal to 0.05. Now n equal to 58, this is a large sample, so we are going to use a z test. So what are the data given? Population mean is 8, sample mean x bar equal to 7.8. Now standard deviation, when you are coming for the z test, population standard deviation and sample standard deviation will be almost same. So we use the same formula. We call this as sigma equal to 0.5 minutes. Now let us take the formula for the z test. This is the formula, x bar minus mu by sigma divided by root of n. Okay, so first you should do this, and this is whole divided by root of n for us. It is equal to, calculate all the values, substitute them here. X bar value is going to be equal to 7.8 minus mu value is 8 divided by 0.5. Okay, what you do is first you complete all this process, then divide it by root of n. Okay, what is n? N is 58 divided by root of n. If you are using the calculator, please use this in this order so that you will not have any mistakes. Okay, so when you are doing this calculation, you will get minus 3.04 because x bar value is small, x value, mu value is bigger. So you will get this value as minus 3.04. But when you are taking the magnitude value of this, we write only positive 3.04. In all the questions you take the magnitude only. Okay, so 3.04 is a test statistics value. So we have calculated one part. Now we want to make a conclusion. So to make a conclusion, we should, so this is a two-tailed test. So when we are having a two-tailed test, we have to check for this line two-tail. Alpha is equal to 0.05, so alpha is equal to 0.05. From this column 1.960, this is the table value for us. So after getting the table value, we can compare them. So put the calculated value on the left hand side, so that is a calculated z, and put the table value on the right hand side, check whether it is coming less than. It is not less than, because 1.96 is a smaller value, this is a bigger value. Okay, therefore this is big and this is small value, so we clearly know that this is not less than. If it is not less than, we can say H0 is rejected. That is our conclusion. Okay.